Because it was like sending huge numbers.
That's so funny. Okay, so you know, kind of like step-by-step strategy to factor polynomials. This is located on the first page of the chapter. You know, I'm not going to go through that step by step. You guys can follow those while you're factoring in your homework. So let's just go ahead and start this chapter and see if we can tackle these guys. Okay. So, like it says in the instructions, right? First you go through and you check to make sure there's no special products that you're getting, right? And so you take a look at whatever polynomial that you're using and you say, does that conform to a special product? Does this look like a squared minus b squared? Nope. What about this one? What about, oops, I think it goes like this, a squared minus 2ab plus b squared. Does it work for that? Why not?
Because it doesn't have a b squared at the end.
Are you sure? What if b was equal to 10?
Actually.
Right?
It could work.
Yeah, remember, the a's and the b's in these formulas, these get replaced by whatever's in your actual polynomial. So if we say, what if a was equal to x? What if b was equal to 10? Then 2ab would be equal to 2 times x times 10, which would give me 20x. That is in fact the middle term. So yeah, this is a perfect square trinomial. And if we go by the formula for perfect square trinomials, we'll see that this ends up being x minus 10 times x minus 10, right, which ends up being x minus 10 squared, exactly. Sorry about all this junk on the sides. And so this would be your final result. But as long as you just check to make sure that it's a perfect square trinomial, like, you know, even this middle step, I'm not going to make you do that because you recognized it's a special product. So you don't, you know, you can just say, that's it. That's all. There doesn't need to be any middle steps if it's a special product because we've already established formulas for those. Okay, suppose they want us to factor this guy. Well, right off the bat, we would recognize, well, first of all, we'd check to see if there are any common terms we can factor out. 5 is prime, x is prime here, so no, there are not any common terms. Then we notice that there are actually 4 terms in this, which typically indicates that it's a factor by grouping example. So we're going to put our little imaginary groups here and see what we can pull out. What's the largest common factor for these first 2 terms? 2? Then what?
X. 3.
X, not cubed, squared, right? Yeah. Remember, if we have the option of a larger number and a smaller number, we can only pull out the smaller number. All right, and so what we have left after we divide everything by 2x squared is just a plain old x plus 5. And then we have x plus 5 over here. Okay, so now I just recognize that I have 2 binomials that are the exact same. So I can pull those out. So I pull out x plus 5 out front. I put in parentheses whatever's left. I have my 2x squared plus
X plus
1.
what's out there? 1 plus 1. Careful, that's one that'll get you. All right, so any questions on that one? Okay, all right, let's try this guy here. So here's a good example of when we need to factor things out before we even start, right? So there is a common term that we can factor out of all this. So it looks like we have at least an n cubed in each term, so we're definitely going to pull out an n cubed. 35 and 2 don't have any common factors, so we can't pull out any coefficients. One thing, yeah, the negative. Nobody likes a negative out front. We want to get rid of that. So we're going to factor out a negative n cubed. After we do that, we have n squared left over plus 2n plus 30. Oh, you guys noticed my mistake? these should be negatives now. Yeah, I factored out a negative, which means all these have to switch signs. All right. So now I just factor whatever's remaining, right? All I need to do is factor this inner polynomial. All right, so I'm looking for, right, this is going to equal negative n cubed. And then I'm going to have two binomials with n as the first term. And that's because there's no coefficient out here, and I only have a second degree term right here. So I know it's going to split up like that.
They're both negative, so.
Yeah, so I have a negative here, negative 35 here. So I'm going to have a negative and a positive for my signs, plus, minus.
It doesn't matter the order that you write these in, does it?
No. You mean like in terms of the plus and the minus and stuff?
Yeah, like the minus, like switch them.
No, it wouldn't matter at all. Yeah, that wouldn't matter one bit, and that's because multiplication's commutative, right?
Right.
Yeah.
A times B is equal to B times A.
Okay,
Even
so
if
it
it's
doesn't
something
matter.
weird like binomials, it works.
Okay.
Yeah, good question. Okay, so now we're looking for P and Q, right? P and Q that multiply to equal 35, right? Such that they equal negative 35, and when you add them, they equal a negative 2. Okay, so real quick, what?
7 and 5
Yeah, and which factor are we going to attach? Are we going to attach the factor? Sorry,
Negative 7.
there you go. Sorry, I was getting tongue-tied there.
Sorry.
So I think Deja called it out, right? It was 7 times. Negative 7 times 5. Negative 7 times a positive 5. That equals negative 35. And negative 7, whoops, that's not a 7. Negative 7 plus 5 equals negative 2. We satisfied both of those, so those are our factors. The 7 goes with the negative, and the 5 goes with the positive. And here's our final result. Oh, man. Oh geez, I can see I typed this in wrong already too. So the y shouldn't be in the exponent up here. This should say 6x squared y to the 4th minus 21x cubed y to the 5th. Okay. So here's a little practice. What's a common term I can pull out of this guy? Think about it for yourselves for a minute before you yell out the answer. What's a common term? Anybody got a guess?
3.
3?
X
Whoops. 3x.
squared.
Good. Then what?
Y to the 4th.
Yeah, y to the 4th, right? All you got to do is look through these, right? You say, okay, there's an x in every term. What's the minimum? 2. That's what we're pulling out. There's a y in every term. What's the minimum? 4. That's what we're pulling out. Okay, so after we pull that guy out, we end up with a 2y. No, that's just a 2, isn't it? We end up with just a plain old 2 in there. After we pull the 3x squared y to the 4th out of the middle term, we end up with a negative 7xy. Agreed?
Yep.
Yeah.
Okay. All right. And then for the last term, after we pull out this 3x squared y to the 4th, we get y
To the 2nd.
squared. Aha. Okay. So I'm going to rewrite this guy because I don't like my squared term being over here. Yeah, I'm a little bit OCD in that way, so I'm not a big fan of that. So I'm going to write y squared minus 7xy plus 2. Okay. Now I have to say, I have to take a look at this guy. And I have to say, if I could factor this, what would it look like? Well, we'd still have the 3x squared y to the 4th out front. What's the inside going to look like, right? And so this is our first term, and so it would be a y and a y. But where does the x come from? if we put an x back here, whoops. Ah,
How was it supposed to happen?
no. What's going on here? Stop. There we go. Okay. I just hit random buttons. Okay, so if we threw an x back here, right, we'd end up with an x in this last term. Right? That's the only way that we're gonna, if we put x's either here or here, we're gonna need an x here. And so if you think about this long enough, it might take you a while. It took me a while. You'll realize you can't do it. Can't be done. So this is prime. One of the indicators is there's two variables in this middle term, but there's no variable back here. Yeah, that's an indicator that it's prime. That doesn't mean it's absolutely prime, but some of these, unfortunately, you kind of have to just think your way through and say, is this even possible? I don't know. Sometimes it's just not. And honestly, if you ran through a few cases with that, you'd realize that it wasn't. But just remember that. Beware.
That would be on the test.
Yeah. All right. So here's another example of factoring out a common term. Right. So clearly, each term contains an x. What else can I factor out? I can definitely factor out a 2. Is there anything larger than a 2?
No.
Nope.
I think you're right.
There's not.
Right? Because this ends up being 49, right?
49.
Yeah. 49. 49x squared. This middle one, this ends up being 140x. And then the last one is plus 100, right? Okay. So this looks like a big pain, right? Like, dude, I don't want to do all the math on this. This sucks. Oh. But what I'm going to notice is that this is a squared term, and this is a squared term. So this is a good candidate for perfect square trinomial, right? So remember, this is the form of a perfect square trinomial. Plus or minus 2ab plus b squared. All we need to do is check to see if it conforms to this, and we can just immediately say we know what it equals. So if a were equal to 7x and b were equal to 10, right, which is the square root of this and this, then 2ab would equal 2 times 7x times 10, which gives me 140x. So yeah, this is a perfect square trinomial. Yep. And then we have, right, 7x, because x is a. And then we have, let's see now, what is it? It's a, yeah, a plus b, not b. 10 squared. And that's it. And so this is kind of why we did that. Sorry, I should have wrote out the entire thing. So the whole thing says a plus b squared equals this stuff, right? So this is something that you're definitely allowed to put on your note card. And as you can see, it might help you out through some of this stuff. That one looked pretty ugly. I didn't want to do that. But it was a perfect square trinomial, so I could just pop it in the formula.
Then you liked it.
I loved it. Okay, here we go again. So, here's one of the ones where we have multiple variables, but this one's not prime. So for this one, I could either, I could definitely factor out a negative, or I could just rearrange it so that the 3n squared is out front, right? I mean, they're both variables, so it doesn't really matter which one goes out front. Okay, so for this one, it's one of the more complicated ones. I have coefficients, they're not both prime, so I'm going to try the method of grouping with these. So I multiply the coefficients of the first and last terms together. So 3 times negative 10, that's negative 30. And then I look for pair factors of negative 30 that add to negative 1, the middle term.
5 and 6.
There you go. Right, and Kevin already said 5 and 6, right? They have to sum to negative 1, so which one does the negative go on? 6. 5 and negative 6. Right, of course 5 minus 6 equals negative 1. That's exactly what we wanted, so those are the two that we're going to use. All right. Almost, right? Well, now we have to split up this middle term, remember? So this is kind of the crucial moment. And so the 3n squared just drops straight down. This negative 1mn breaks up into a positive 5mn and a negative 6mn. You might be very tempted to split up the m and the n, but don't do that. That's what my instincts always tell me to do too, and it's just wrong, right? I'm always like, oh, maybe it's 5m and 6n. No, you keep the m and the n together. So now that I've split them up, I'm going to go ahead and propose some grouping symbols and see if I can factor some stuff out. So for these first terms, 3 and 5 are prime, but it does look like both terms contain an n, so I'm going to factor an n out. So n comes out, and I have 3n plus 5m. Okay. Yeah, so both of these terms have negatives. I noticed that my terms over here that I'm trying to match, these don't have negatives. So I'm going to factor the negative out of those last two terms as I do this. So I'm going to factor definitely a negative out. What else can I get out? I can get a 2, because both of those are divisible by 2. And I can also pull out 1m. All right, so after I do that, I have 3n
Plus 5m.
plus 5m, exactly, and that's exactly what we wanted. Now we have our matching factors.
Now last step.
Right, last step, you pull those guys out front, 3n plus 5m, and you write what's left, n minus 2m. Notice that the negative sign came down with the 2m. All right, so that's it. Then we multiply those together to check our work. You multiply those together to check your work. Okay. Okay, so this one's a little bit weird. And it's only weird that we have to just rewrite the first step to really understand what's happening here.
Because we have an x and a y.
Yeah, because there's both x's and y's, and we're used to just a single term up here being squared, right? We're used to a squared, you know. So what we need to do is just treat these like a single term. So we rewrite this, right? We reverse the distribution of this exponent. So we write this as xy squared plus 7xy plus 12. Yeah, and now instead of an x squared, we have the whole thing xy squared. It still factors out the same way though, right? And so if you had an x squared, you have two leading terms of x. Since we have an xy squared, we have two leading terms of xy. Good, yeah, they're both positive because we have a positive final term and the middle term is also positive. So they must be both positive. So what we're looking for is P and Q such that P times Q equals 12 and P plus Q equals 7. Can we think of those without even making up a table?
3 and 4.
3 and 4. Yeah. Sorry, I almost said 6 and 2 as well. Me and Bella were on the same wavelength on that one. We were incorrect though, Bella, sorry. Yeah, 4 and 3, yeah. All right, since they're both positive, we don't need to worry where the 4 and the 3 go. We just throw them in there wherever we feel like it. And that's it. And of course, FOIL that guy out just to check. All right, so this one. Does this conform to any of our special products? Sure it does. This is the easiest one for me to see, difference of squares. It's like, oh yeah, they're both squares. So I'm just going to rewrite this in terms of its squares. So I have a squared, right, minus 4b squared. So my capital A is equal to little a squared. Sorry, that's an unfortunate choice of variables. My capital B is equal to 4 little b squared. All right, so now all I need to do is plug and play with this formula. So I have capital A minus B, so I have a squared minus 4b squared. And then I have capital A plus B, so I have a squared plus 4b squared. So I might be tempted to stop right here. But what I'll notice is that I can actually factor out one of these two. And I don't know why I highlighted them both, because it's only the one on the left. So, sort of an indicator. So, the polynomial on the left conforms to this guy, right? A squared minus b squared. So that means we know it's going to factor out, right? Because square root of 4 is 2, square root of b squared is b. But one thing to keep in mind, like as you're going through your stuff, if this is a plus sign, it's never factorable. It's prime. You can just say that automatically. It just does not factor. And that's not really something that we go over much in this class, but it's just something that you should know because it can save you a lot of time. If you come down to this, one says plus and one says minus, right? A squared plus b squared is simply not factorable. It can't be done. But this one still can, so let's split it up. So, once again, this is an example of a squared plus b squared. It's just inside the factor we already worked with. Right? So, in this new one, capital A is equal to little a, and capital B is equal to what? Capital B is equal to 2 little b. So I have a minus 2 little b and a plus 2 little b. And then this one drops straight down because it was prime. And there we go. And that's it. And so so you go ahead and circle that guy. Of course you FOIL it all out and make sure that it equals the same thing. But that's that. Okay, so that was the section on general factoring. You know, make sure you practice this stuff a lot. You'll see in the next section that we're going to use this to solve basically all polynomials with degree 2 and above. You know, and so like we've solved single degree polynomials so far where we just have x equals 5 as the solo answer. But from now on, we're going to start solving larger polynomials like this one here. Okay, so let's go to the next section. All right, so in this section, we go from factoring into solving polynomials. So to do that, we've got to talk about what is called the principle of zero products. And to understand this, we really just have to think about options when we have variables, right? And so this first case, right, we consider what if we had some xy that equaled 6 when we multiplied them together. So there's really only 2 possible cases that xy can be, right? Either xy is equal to 1 and 6, or xy might be equal to 2 and 3. Right? Those are the possible cases if you had x times y equals 6. Now, suppose we had a prime number. When we have a prime number, there's only 2 options for these, right? A either equals 1 or 3, and B either equals 1 or 3. There's only 2 options that could possibly be in the world. Now, suppose we had those 2 variables that equal 0. So for this case, right, we have to say for this to be true, either x has to be 0 y has to be 0, or they both have to be 0. Those are the only cases that are going to make this true. And that's kind of, we use that logic to solve all of our polynomials. So that takes us to the principle of zero products. Principle of zero products just says any equation a times b equals 0 is true if and only if one or both of those factors equals 0. Okay? So when we say we want to solve this equation, that means we want all values that make this equation true. Right? And so just like the zero product that says if a times b equals 0, either a or b must equal 0, we just have to say, well, this equation is true when this first factor equals 0, this second factor equals 0, or they both equal 0. And so we say this equation is true when we pick a variable that makes that true. So what value would make this first factor 0 for x?
X plus 3, x minus 3?
Yeah, x minus 3. And here's how so I split this up, right? And I say, okay, x plus 3 equals 0. Suppose that were the case. And then I solve for x. Add 3 to both sides, I get x equals -3. So x equals -3 is one of the answers to this problem. Then I need to do the same thing for this factor. Yeah, that would be positive 2. X minus 2 equals 0. X equals 2. And that's it. Those are the two values that make this equation true. So those are the full solution set for this equation. That's it. That's all you need to do to solve a polynomial. You factor the whole thing out, set it to 0, and then you solve each and every factor for 0. So for this guy here. So I'll start with this factor out front. You have to do this for every factor, right? It's a constant term. Is there any way this is ever going to be 0? No, not unless we completely change the problem. So I don't need to worry about that. If there were a variable in it, then I'd have to worry about it. But there's none. So this next one, I have to say, when does 5x plus 1 equal 0? Well, I'm just going to do a little bit of algebra to figure that out. If I subtract 1 from both sides, I get 5x equals a -1. And then if I divide both sides of that by 5, I get x equals a -1/5. So this second factor equals 0 when x equals -1/5. So that's one solution. Yep. This next factor, we do this one in our heads. When does that guy equal 0? +7, right? If x were a +7, this other factor would be 0. So x equals +7 is the other answer. And that's it, right? And so, yeah, that's it. Like, that's how we solve equations, right? We've done the hard part already. We've learned the factoring, right? This is the easy part. After you get done factoring, all you do is solve each and every factor for 0, and those are your answers, right? And that's why factoring is so unbelievably important here, because like this stuff is easy once you learn how to factor. Factoring's the tough part. Okay, so here's a good one. So for this one, we actually do have a factor out front with a variable in it. What would I plug in for t in this 7t to make the whole thing 0? Sorry, this should say equals 0. How about this? 7t equals 0. Divide both sides by 7. And we have t equals 0. So t equals 0 is one answer to this. Does that make sense?
Yeah.
Yeah, so like I said, set every factor equal to 0. And if there's no, pluses and minuses, it's just a multiplication, it's 0. That's it.
It will only be, no matter what, no matter what, or 0.
Yeah, exactly. Yeah, if I had if I had 5, whatever t, times t minus 5 equals 0. One of the answers to this is 0, because if I enter in 0 for this t buried in here, the whole thing turns to 0, and it makes it a true equation. Okay, so one of the answers is 0 for that. Yeah, the next factor, if we set it equal to 0 and solve for t, we would get t equals positive 5. Now, if you ever want to check your answers on this, which for this one you don't need to check your answers, it's like super obvious. But for this last one, like, you know, we got t equals negative 1/5. If you're not so sure about that, plug in negative 1/5 here and make sure this all equals 0. Right? That's how you check your work on these. Did I just hear somebody go, ugh? That was awesome. All right. So here we go. So we just went over how to solve prefactored equations. Just went over how to break my computer. There we go. So we just went over how to solve equations that are already factored. Obviously, if you get an equation that's not factored yet, you just have to factor it first, then solve it. Yeah. So, okay. So for this one, how about you guys work on this one all by your lonesome? Try and figure this one out. Try and factor it. Give me some solutions. Don't yell them out, though. Speaking of that, where'd Gabe go?
I don't know.
Oh, well.
Probably in your office.
But it's not still here.
Nah, don't worry. He's fine. He knows we're here.
Oh.
What do you guys think? Anybody got her solved yet?
Yes.
Is it? That's because I got these right out of your book. Sometimes I change them. Sometimes I'm just like, no, I'll just do this one. It's fine. So what did you guys get? What does it factor out it to? Tessa?
X plus 2 times x plus 3 equals 0.
Very good. And so
And so like,
what does that mean the solutions are?
Is if you add
X
-2,
-2.
-3.
Yeah.
And I don't have their book.
Yeah, I'll have to change these next time. So that was it, right? So we figured out how to factor this guy out, and then we solved each factor for 0, and then wrote down our solutions. Okay, so for this next one, so first of all, like to factor any polynomial, we set it equal to 0, and then we factor it out, right? So, so what we need to do, since it's already set to 0, we need to fully factor this side out. You might be tempted to try and come up with some reverse FOIL, but you should notice first off the bat that there's an x in each of these terms, and so that's going to really solve all our problems. So if we pull out one x from each term, we get x plus 7 remaining, and now we can solve this really easily, right? And so don't push yourself to do this like FOIL thing every time. Sometimes it's as simple as factoring out a single variable. Okay, so now that we've factored this out,
So X equals 0.
right, this variable up front, the whole equation equals 0 if this x equals 0. So x equals 0 is one answer.
X -7.
Right. The whole equation is equal to 0 if this second factor is equal to 0, and that happens if x is equal to, like you guys said, -7. So those are my solutions. Okay. Here's an example where it's not set to 0, right? The only thing you do when it's not set to 0 is set it to 0, right? It's not too complicated. So all we need to do on this is add 16 to both sides, and we get x squared minus 8x plus 16 equals 0. Anybody know how, actually, why don't you guys pause and try and factor that guy out? Factor out x squared minus 8x plus 16. Try and do it without your book before you look at your book. I know those are tempting to check out. But remember, math is not a spectator sport. Jarrett, you nailed it. Okay. Right, and so for this one, we're looking for some P and Q.
Such.
Yep, such that they equal 16 when you multiply them together, but when you add them, they equal a negative 8. Sorry, they equal, yeah, negative 8. Anybody got them? Go ahead and yell them out if you got them. Tessa?
They're both 4,
Good job.
but I don't know which one to put in negative or which one to put in positive.
Well, that's
both
easy.
negative.
Excellent question. So we know that because we have a positive 16 right here, which means they're both positive or they're both negative. We have a negative in the middle, which means they're both negative. So we have x minus 4 and x minus 4. We can go ahead and honestly, like, you don't really need to even simplify this, right? And so if we solve one of these for 0, we have both of them. So what's the solution?
X minus 4.
Right, x minus 4 equals 0. We have to solve that to get the solution. So to solve that, we just add 4 to both sides, and we have x equals 4. Since that is the number that renders both of these 0, that's the only answer that we need.
It's single.
Yeah, and that's really like, you know, if you have, if you start out with something that has a square on it, you'll typically boil it down to 2 different answers. You know, they're only the same if it's something like this. Okay, for this next guy, once again, I want to set this equal to 0, so I'm going to subtract 25 from both sides. Okay, now, given what I'm about to write up here, you guys solve this. Right? There's a perfect example of difference of squares. Put that whiteboard into use, Gabe. You don't have the pen? Dude, I have a whole chalkboard full of them up here.
Is it technically a chalkboard or is it a whiteboard?
You know what I mean. Smart Alec.
I'm over here in my head.
Can you tell us the answer?
Yeah. Okay. So if you guys check this out for long enough, you would have seen that you can rewrite this in terms of squares. You can rewrite this as 2t squared minus 5 squared. So this breaks up into our difference of squares formula. So I get a plus b and a minus b. If a is equal to 2t, then I get 2t plus 5 and 2t minus 5. Right, okay, so now I'm going to go ahead and analyze this and find out what t is over there. So I'm going to set that equal to 0. 2t plus 5 equals 0. If you subtract 5 from both sides, you get 2t equals negative 5. And then, of course, if we divide by 2, we get t equals a negative 5 halves. All right, so that's one solution. Now the next one I find by setting this factor to 0. And you'll see that they're very similar when we get down to the end. So for this one, I have 2t minus 5 equals 0. If I add 5 to both sides, I get 2t equals positive 5. Then if I divide by 2, just like I did in my previous, I get t equals a positive 5 halves. All right, so those are both my two answers for this problem. And just a heads up, like, I knew I couldn't break this down any further because there's no square on there. If there was a square on there, then I'd try, but there's not. Here's one that you'll get sometimes, and they do this just to annoy you. This one, like, it's like, oh, they factored it for me, but it's not equal to 0. So you gotta FOIL it all out, collect it all again, factor it all again. I don't know what's going on there. Come on. There we go. All right, so here it goes. So I'm going to FOIL out this left side. That's going to give me 2x squared, right, times negative x, and then I have a plus 6x, and then my last term is minus 3, and that all equals 9. So that gives me 2x squared. Yeah, you will. Yeah, we will in just 1 second. We'll subtract 9 from both sides on this step. So I combine these two, which gives me a plus 5x. Then I have minus 3. And then I'll subtract 9 from both sides on this step above here. So I have minus 9 equals 9 minus 9. These guys go to 0. Now I have 2x squared plus 5x minus 12 equals 0. Okay. Now, you guys get to do this one. Go ahead and factor this guy out. This will be good practice for you guys for these weird ones with the coefficients out front. Remember, the easy method for this is you multiply together the coefficients on the first and last terms, and then you find factors of that number that sum to the middle term. Hmm?
The x that's as far as I've got. I can't go anywhere else.
Oh, you got to this step here?
Stop right there. Not continuing on.
Anybody got it? We got some practice to do then, huh? You think you got it? What you got, Deja?
X plus 3 halves.
3 halves?
3 over 2. And then a negative 4.
Interesting. So that can't be it. And that's only because negative 4 times 3 halves is not negative, oh wait, yeah, is not negative 12, right? And so what we would need, yeah.
3.
So,
It's 3.
so this is how we should approach this problem. So we're looking for factors of 12 to go here and here, right? If we want to do the guess and check method, we can just say, oh, 2 factors of 12 are 3 and 4, right? What if we multiplied 4 by 2 and then subtracted 3? Would we get 5? Yeah. I know that's a terrible way. That's, yeah, okay. So that's just me kind of like working things out in my head. But you know, after you do enough of these, you'll get it to work out in your head. So anyway, let's do it. Let's do the whole thing.
24.
All right. So exactly, negative 24 is our first coefficient times our last coefficient. Right. We want pair factors of 24 that sum to our middle term, which is 5.
8, 3.
Hey, good. 8 and 3. And so we'll have, it's a positive 5, so we'll have positive 8 and negative 3, right? Oh, were you just giving me solutions, maybe? I'm sorry. I totally was just like, "Meh, that's the wrong way." No, my apologies. Yeah, you probably have the answer. I think you actually did. That was my fault. So, okay, so yes, 8 minus 3 is 5. I do that sometimes. 8 minus 3 is 5, right?
Plug that in.
Right, but we don't really plug it in yet. So this only works if we do the mental method, right? Our next step is we got to split up that middle term into what we just found it should be.
Oh, yeah.
Right, yeah. So this guy drops straight down. We get 2x squared. The 5x splits up, and that gives us plus 8x minus 3x minus 12 equals 0. Okay, now I try and pull out whatever I can. In these first 2 terms, it looks like I can pull out a 2x. That leaves me with an x plus 4. In these second terms, it looks like I can pull out a negative 3, which leaves me with an x plus 4. My 2 terms match, which means I'm on the right path. I can pull those ones out front, x plus 4, oops, plus 4. And then I put whatever I have left, 2x minus 3. Now we go to where Deja was already at, and we say x must equal negative 4, because that's what's going to turn this first factor into 0. And, what was it, a positive 3 halves. Yeah. Nice job. All right. Any questions on those ones? Okay. All right. So here's kind of an idea of what we're doing graphically. So this is a graph of this particular polynomial equation. This problem wants us to find the x-intercepts of that graph, right? Which is tough to do by just looking at it because there's no tick marks on this at all. And so what we're really doing when we set a polynomial equal to 0 and then solve is we're solving where this graph crosses the 0 line.
Well, both like 0 lines, right? That way. Y-axis is 0 and the x-axis is 0.
Not the way that we're looking at this, not with this function. Yeah. Yeah. The y-axis is more like time equals 0, you know, or something like that. The x-axis is more like the value equals 0. So for this one, if we wanted to find the x-intercepts of this, we would just set it equal to 0 and solve.
Y equals 0.
Yeah, exactly. Set y equal to 0. So we have x squared minus 4x minus 5 equals 0. We want to factor this out. What are two numbers that multiply to negative 5 but add to negative 4?
Negative
1 and 4.
5.
Negative 1 and 5.
Negative 1 and 5.
5 and negative 1.
Negative 5 and 1. Right? There we go. Yeah, you guys, I had to think about that for a minute, right? Negative 5 and positive 1, right? Because we needed the negative 4. So now we can say, okay, solve for x. For this one, x must equal positive 5. And for this factor, x must equal negative 1. And so we can say this point is x equals negative 1. And this point is x equals 5. So another thing to sort of remember about this, that this last problem can tell us, sometimes we don't want to know where a function crosses the x equals 0 line. Sometimes we want to know, suppose we want to know when the value of this function is equal to, I don't know, 6. Right? Suppose this is the 6th line, and we want to know what's this point here and what's this point here. If that was the case, we'd set y equal to 6 and solve the whole thing again, right? And so we'd say, oh, okay, x squared minus 4x minus 5 equals positive 6. Then I'd set it all equal to 0, factor it all out again, and solve for x. But that x would tell me this point instead of this point. Okay? Gabe, you got a question?
Is this preparing us for the example of y equals fx plus b?
No, not really. We're sort of past that example. This is
We're going into graphing of what the solution is.
This is preparing you guys to be space cadets. I don't know. It's just math, dude. It doesn't prepare you for anything. Don't tell anybody I said that.
That's recorded.
I gotta edit that. Okay, so that's today's class.
You are done.
Right? All right, got that piece out, right?
I'm looking look like.
Yeah. So,
Such as.
any questions on these? No, Manny? Okay.
It
If you
seemed
guys
a lot
want-
scarier looking through this chapter. That seemed a lot scarier now that you understand it. It's
Yes. These are very scary looking problems, especially when they have two variables involved, things like that. But as the extra credit problem on the last exam should show you, just because it looks scary doesn't mean it is, right? Like that extra credit problem turned out to be the easiest equation you could ever come up with, y equals x. But it just looked scary, right? Even the person that got it right wrote a question mark at the end, like y equals x? And yeah, it was right. But you know, it's like scary problems, just because they look scary doesn't mean they're tough. It just means you might have to take that first step and then figure out what's going on. Gabe?
So that one up there where you got x plus 4 and 2x minus 3 equals 10. I ended up getting the same thing using
Your magic X?
the magic x.
Excellent.